Okay, guys, welcome back. And our next talk is from Robert Klotzner on the Gonimo architecture. If you could join me in giving him a big London Haskell welcome.
Thanks. Thank you. I'm going to talk about the Gonimo architecture today. Gonimo is a baby monitor I wrote. So let's start with a little bit of background first. In 2014, I became father of twins. And I did what every father does. I developed an open source web-based baby monitoring application because that's what people do. I even got some funding for this, so it really came to life because otherwise I would probably have been stuck with the first version. It was a very simple application, just yes-dot application with some JavaScript gluing it together. It kind of worked for us, but it wasn't really great. But we got some funding, so in 2016 I wrote a proper PureScript front-end for it. And in 2017 I decided to do a rewrite and went full stack Haskell based on Reflex. The last one is the one I'm going to talk about today, so the Reflex version of Gonimo. So how did that work out? I have to start with, I was already at the end of the project, at the end of the funding, so I was kind of in a rush to get this done. So I basically just started coding, didn't think much about architecture and how to build all this stuff together. I just coded because I needed to get it out. So, well, it was lacking structure, so I had like functions with like 7 parameters. I had like giant functions, and if you think that's not too bad, that was just a function in a where class. So some other issues I had. Like you've seen before, bloated, hard to follow code, no really clear structure, at mixed level of abstraction, which I've seen a lot in Reflex-based code, where you just have, huge functions are pretty common in Reflex. I've seen them a lot, and I personally find them really hard to follow. Like you have a function that is supposed to describe like the whole screen of an application, and you have like 30 lines of code describing some button somewhere. That's just distracting. What I partly resolved, I have a background in C++, so I developed using the Qt applications before. And what I really came to like was model view controller, the pattern. It just makes working with the code so much better if you have to restructure stuff and things like that. So I tried to avoid distributed state in UI code. I tried to separate logic from the user interface. I did that, but I was kind of restricted because, I was very new to Reflex and pretty soon ran into issues like, blocked indefinitely on MVAR and stuff like that. So I just figured out, okay, some way to make it work, which was not really perfect, but it somehow worked. So it still was kind of a bit, adding a new feature was like, okay. And restructure user interface a bit because we found that people find it more easier if you did it that way, was like, so it was just a mess. And I have to admit, I'm really exaggerating. I really just wanted to add dramatic pictures. It wasn't that bad. The PureScript version was that bad. In Reflex, it was already much better, so I knew I was on the right track. But I was sure it can be done better. So I leaned back a bit and thought, okay, how can I implement a proper MVC? And I had some good talks at last HaskellX Exchange, which inspired me. So I came up with something. What were my goals? Well, as I mentioned before, model view controller is something that's really worth it. You have some upfront cost for it because you have to have this additional model layer, but in the end it pays off because restructuring your code, if it's live code and you work on it, it just pays off in the end. Especially if you have state in the UI code, that really sucks because you have it there and then at some point you will need that state somewhere else. So you have to wire it. It's just horrible. So don't do that. I really like modular and layered code. So I like to have my individual components with a clean interface, where it's clear what goes in, what goes out, maybe hide some internal stuff that's not relevant to the user and stuff like that. As mentioned before, what's important to me is making it easy to work on a single layer of abstraction. So if you are at like on a high level, you shouldn't have it cluttered with all the details that are irrelevant at that level. So basically make the code readable. Yeah, UI rearrangement should be easy. I wanted to have a clean architecture. I often find myself in code bases, if you need something, you're just scrapping. You're just wrapping for stuff, which is fine, but it shouldn't be like demanded. Yeah, it should be, if you take a bit and understand the structure of the project, it should be clear where what code is. Well, and we're Haskell developers, so it should be robust against coding errors. It should be hard to introduce runtime bugs. In particular, I wanted to avoid error-prone boilerplate, like boilerplate that can go wrong and you will cause runtime bugs. That's not saying the architecture doesn't have some boilerplate, it does, but it's type checked and it adds structure, so it adds value. I compare it to function signatures in Haskell. They are not really needed, but we do them anyway because they help understand the code. And you can't get them wrong because if you write them, you will get an error. So what is covered in this talk? I'll start with the heart of the architecture, the component. I'll explain a bit what I understand by a layered model. An aspect that's really, that was something I got, the idea came from the last Haskell exchange, configs and monoids. That's really useful. I'm going to dive a bit, why are the type signatures in this architecture quite polymorphic, why this is useful. We're going to put it all together, well, and then there are some pitfalls. And yeah, we'll have a short summary of what's. So, the component. A component, an idea that you will get pretty soon how you could build components is this. Why? Because if you look, for example, in Reflex DOM, you will find widgets like text input. So it takes a text input config and produces the component like text input. So if at least for me it was so, I was reading Reflex DOM code, and so I got, okay, I will structure my components the same way. I will just take a config and produce some component. And I did that in the first version. The problem is if you're not building a library, but an application, you usually will have quite a bunch of dependencies on other components. And if you have those flat configs, you will end up with a lot of tedious and fine-grained wiring. So I arrived at a bit of a different architecture, this one. Instead of having just one input, the config, we also have a model, which is specific to the component. It's basically the dependencies of the component. So all the components it depends on are in the model. It will take a parameter model which is just the components it needs for its operation. To the outputs, we don't only return the component, but only a model config, which is the configs for our dependencies. So there's some structure to this. I like to think of the config and the component as the interface. That's the public-facing part, which will you be using in other components that depend on this one to interact with it. You will provide a config for it for triggering actions. A config usually consists of events that just tell the component to do something. And you have the component with usually the dynamics, which hold, well, the state of the component, so you can access it. The other part is the implementation, which you really care about when you're constructing the component. You will need to pass in its dependencies, the model, and you will need to wire back the configs for its dependencies. And of course, the builder function is also an implementation detail. So to make this a bit more concrete, I have a running example. It's the account component in Gonimo. So it's an abstraction we have. And an account can be part of a family. So we can group accounts together, which is basically a means of grouping devices together so they can see each other. So one can be a baby monitor and the other can be the parent station. So that's the coupling of the devices. In order to get a device to join a family, we have invitations. So an account can claim an invitation, and you can tell him it to do so by providing the onClaim invitation event. Just send it, and it will claim the invitation. You can answer it, reject, or accept it. And you can create a new family where you can send out new invitations for others to join. So that's the config. The component is this account. It has an identifier. It has claimed invitations, which are the invitations the account currently has claimed, and the families it's currently a member of. Well, now the interesting part, the model. What does our account need for its operation? It needs the server component we have, which basically offers the possibility for getting messages from the server. So it will be able to receive messages from our server. So it has access to authentication state at host for host-specific functionality. So the model config is the output, like what we will be providing, how we configure dependencies. So we have a dependency here on subscriber. So account is able to subscribe to change events on the backend. And server config, so it is also able to send messages to the server. And then the builder function, which I usually call make. And this might be interesting because, as you see here, our signature is pretty polymorphic. We don't have concrete types. The model is not it's just some arbitrary type, which has the constraint has model. The same for the config, has config, and the same for our return value, the model config. It just needs to satisfy has model config. And we're going to see in a minute why this is very useful. But first, I'm going to tell you a bit what I understand by a layered model. Let's look at the subscriber component. It has two dependencies. It needs a server, it needs auth. Let's look at the model as seen by the server. The auth component, it just needs access to the server. The model of the server component is just environment, which is an abstraction for providing details like where does the server reside, the URL of the server, and stuff like that. And the model of the environment is nothing. Yeah, it doesn't have any dependencies. One interesting aspect is it's really useful if configs are monoids because it eases the wiring quite a bit. You get less wiring, you get smaller functions. Unfortunately, I won't be able to go into details about this. You have to trust me on that. It's less error prone. You have easier restructuring and good composition. Let's have an example. This was a configuration I had before I introduced this architecture. And you see a lot of fine-grained wiring is needed because the configs are flat. So I ended up with many configs of components basically having the same elements. Like all components that needed some to interact with the server will have that. So you needed all this fine-grained wiring. In comparison, with monoids, you just end up, if you split up your component into smaller pieces, you're just concatenating those configs and be done with it. And the nice thing, first of all, it's concise, and second, you can't get it wrong. Because if you miss some of the configs, you will get a warning that about an unused reference. You will add it, and you're fine. So, OK, all good. But why do those polymorphic type signatures? A quick recap, that was our signature. We have those polymorphic parts. So why do we do that? The Hash model looks like this. This is defined in the account model, in the module of the account component. And it says, like we've seen before, we have a dependency on server, on host, on auth. So we can provide it with a data type like this, and it will satisfy those dependencies. So you can test and also integrate maybe in other contexts those components by simply providing this data type, and it will work. But those constraints are also satisfied by this one, which happens to be all the components we currently have in Gonimo. The same goes for model config. We have those constraints, and you can satisfy it by this simple config, but also by this one, which again happens to be the configuration for all the components we have in Gonimo. So let's put that all together and see how this plays out. This is the top-level wiring we have in Gonimo. So what you see here, we are basically making all our components. And let's have a look at our example component account. So we pass in the model, which is quite unsurprising. And this part might be surprising. We're passing in the model conf. As you've seen before, the model conf is actually the output of the component. So it actually should be this one. This is the model conf our account.make function will return. So what's going on? Let's see what we are going to do with this account conf. As you've seen before, we are just concatenating them with the configs of all the other components. And by means of mfix, we are passing it back in. So the interesting thing is, because of the type signatures of all those make functions, they will pick from this global model config the stuff they care about. So the router will take its own config, and our account component will take its config. It can't even see all the other stuff. It doesn't matter to it that this configuration is a whole application config. It has no way of accessing those parts. And interestingly, this also means it's not possible in that case to write an infinite loop, except if you resort to recursive inputs, which we usually don't do in Haskell. So if you don't do recursive inputs, you actually have not really a way of introducing an infinite loop. And this is possible because of our polymorphic type signatures, because those configs, as said before, is those application configs. So they are those make functions generating those application level configs without knowing it. And then we can just concatenating them and passing them in. And yeah, as mentioned before, you can't get it wrong, because if you miss one, you will have an unused reference. And for the model part, most components return some component. And we're just building them to our application level model together with record wildcards. That's not strictly necessary, of course. You can just add them manually. I know that the extension is quite controversial. I didn't like it at first too, but it's really useful here because, first of all, the arguments against it doesn't really hold here because it's pretty clear what's going in there because of the convention that we prefix all the record fields with underscore. So I can see immediately what goes in there. Yeah, it's totally clear, especially if you're a bit disciplined and only use one of those. So it's fine, but if you don't like it, don't use it, just write it. It will work the same way. You can't get it wrong either, because again, you will get warnings if you don't include it. So that's fine. So yeah, one thing which is really nice. The last part here is our user interface. And you can see it basically as just another component, but it's somehow special because it doesn't take a config, which makes sense because the goal of this architecture was that the user interface is just a user interface. Yeah? So you should not be needed. You should have no need to tell it to do something. So it just takes the model and renders it. And it doesn't produce a component because it should not hold any state that's relevant. So we are producing just a configuration for all the other components. So it's nice that you can see at the type signature that I reached my goal. That's somehow cool. One more to the UI. It looks like this is very monolithic, but it really is not, because every UI every part of the UI also just specifies the dependencies it has on components. So if you have some part of the UI that only needs server, for example, you will be good with just passing in the server dependency, and you can use that part of the UI standalone. And especially in the UI part, the appending of configs is really, really nice because it shortens the code that much. Well, what were the pitfalls I had? If you do model view controller, and you will end up wanting to show the current state of your model in the UI usually. So you have the updated event of your dynamics that you can use to update the state, but it's easy and tempting to just sample some dynamic to provide some initial widget with and it's tempting because of the type signatures of the libraries like reflex DOM, where you have some initial value, which is just static. So it's tempting to just sample it and put it there. The problem is that doesn't really work most of the time because you will get cyclic dependencies. So that was like the first thing I had a problem with reflex. Like it didn't fit the way I wanted to build my applications. So you get errors like this, or it just doesn't load. Well, just don't sample in UI codes. I had, in Gonimo, I actually had a different solution, like just delaying the UI a bit, so I would wrap it in a const dyn, and this was good enough, so I could do the sampling. I recently found an even better way, I think, use post-build. So post-build is an event you get which triggers when like everything is wired up, and then you set the value, and it will work just fine. Yeah, one thing though, how are we in time? It's not too bad, I think. Okay. Like the Gonimo architecture is kind of a pure architecture. You pass around values. You have parameters, you have return values, which is nice. But it's also sometimes tedious with things like network view or dyn, like it's called network view and dyn. I forgot to ask a question. Who of you has coded with reflex before, actually? Okay, that's good. I hope I hope it's somehow clear for the rest. So dyn or network view is a way of, if you have a widget in a dynamic, to render it to the screen and change the network on the fly. But it also can get pretty annoying, because if that widget is returning some value, you get an event of that value. And usually, this will be another event, so you have to unwrap it. And even worse, in the Gonimo architecture, it usually just isn't an event, but a whole config. So you have to unwrap the whole config, which is tedious. So I ended up having a type class, flattenable, which every config is an instance of, and had a helper function network view flatten that just does a network view and the flatten afterwards. So you just get the contents out. So, and together with this, that also works really nicely. So in summary, MVC is awesome. MVC with reflex is awesome. MVC with reflex is possible, because I wasn't sure about this in the beginning. monoids are cool kids too. And yeah, that's it. Thanks. Yeah, sorry. One thing though, I couldn't possibly pack everything in the talk. It's just an overview so you get an idea. If you want to know more, I wrote one blog post. It's just part 1. I should at some point write part 2. And yeah, check out the Gonimo source code because that's running code. So obviously I figured out how you will find a solution to a problem in the code because otherwise it wouldn't work. Yeah, thanks.
Questions, anyone?
So when you had one function that you used to like actually do all of the UI rendering, and the input to that function was the model, right? You had to make UI and it took the model.
Yeah.
So in that model that it takes, the fields of that were, does that include like the states produced by all of the other components that you had initialized?
Yeah. Yeah.
And so do those states tend to be like dynamic values
Yeah.
in Reflex?
Yeah, usually they are. Yeah.
And then the UI component, it's producing what, a stream of events of what people like have clicked on in the UI
Exactly.
and so on?
Yeah.
I see. Okay, that was my question.
Okay.
Anyone else? All right, well, let's thank Robert again. Great talk. Thank you. You can be first at the bar for lunch.